So using the same information we just talked about, now we're going to talk about the next objective and use the sampling distribution of a statistic to evaluate a claim about a parameter. So a newly built Kroger decided to install a Reese's Pieces candy machine that claims to have 35% orange candies. Brittany's favorite flavor is orange, and she was upset when she took her sample of candies and only received 4 orange out of the 25 candies. Brittany started to question whether Kroger's claim about the proportion of orange candies is true. To investigate this claim, she used technology to simulate taking 150 simple random samples, size 25, from a population that truly does have 35% orange candies. The dot plot shows p hat, the proportion of orange candies from each sample. So this was a simulated sampling distribution where there are 150 samples represented here, and it plots the proportion of orange candies from each sample that was taken. Now, it's important to note that this simulation was done from an actual population that had 35% orange candies. So she's going to use this. This is what we would expect to see if the proportion of orange candies was 35. She's going to use this information to evaluate their claim about the candy saying that there's 35% orange in there. So there's one dot on the graph at 0.64. Explain what this value means. So they're talking about this dot right here. We're explaining what this dot is. This is a simulated sample of 25 candies that had 64% orange candies. Each of these dots represents the proportion of orange candies in a sample. For example, these 3 dots right here represent 3 samples that had 16% orange candies. All of these dots represent samples that had 40% orange candies. So is the dot plot above a sampling distribution? Explain. And technically, no, it's not, because it's only a simulation of 150 samples. The sampling distribution of the statistic p hat would include all possible samples of size 25. This is a simulation that is only 150, whereas if there's a population of candy machines, you can take a lot more than 150 samples of size 25. Again, the sampling distribution includes all possible samples and the proportion from those samples. So this was not technically a sampling distribution. So finally, using Brittany's sample as evidence, do you believe that Kroger's claim about the proportion of orange candies is true? Justify your answer. So let's write out what we know from Brittany's sample that she took. Here's the info that we have about Brittany's sample. Her actual sample that she took, 4 out of the 25 were orange. So that would be 16%. Her sample statistic is 16%. So if you think about it, they're claiming that there's 35% in this candy machine. So her sample, we should expect it to be a good estimate of the population parameter of 35. So the population parameter, P, is not equal to her sample. Now, there could be 2 possible reasons why. This idea of sampling variability. Samples are going to vary from one to the next. They're not always going to give us 35% if we keep taking samples from this candy machine. The other explanation for why it's different is maybe the population parameter isn't actually 35%. So we want to know, do you believe Kroger's claim based off of Brittany's one actual sample? So the only way we can make inference or we can make a conclusion about this is by looking at the simulation they did. So this simulation right here, they did a simulation from a population that had 35%. We know that all of these samples, these 150 samples, came from a population that had 35% orange candies. So what we have to ask ourselves is, how often did a sample of 16% or more extreme occur? So we look here and there's 1, 2, 3, 4 times, because 16 or more extreme would be that small or smaller. It only occurred 4 out of the 150 times. So 4 out of 150 times, that is 2.7%. 2.7%. So if there was 35% orange candies in the machine, it would be very unlikely that Brittany would get a sample proportion of 16 or fewer by chance alone. So this can help us to rule out the first option of sampling variability. And now we're starting to wonder, we don't think that there's 35% orange candies in that machine, because if there were, we got such an unlikely outcome. Since the simulation was done using a population where the proportion of orange candies was 35%, and there were only 4 out of 150 values of p hat less than or equal to 16%, we have evidence to doubt Kroger's claim that the machine has 35% of orange candies. A sample proportion of 16% or less, is very unusual, and sampling variability is not a plausible explanation for the difference between the observed proportion and Kroger's claim of 35%. So again, really what you have to do is you need to look at the simulated sampling distribution and see if 35% of the candies really were orange, what's the probability of getting 16% or fewer in a sample of 25? And it only happened 4 out of the 150. That means the true proportion in the candy must not be 35, or it must be lower based on Brittany's one sample that she took.